This part is basically a revision about the high school mathematics you have learned. If you have taken A-level, IGC, SE, IB or something similar, you'll probably see most of the thing here. So 1 appear 3000 BC. So basically numbers start with 1. And in the ancient time, people don't have 0. 0 means nothing, empty, vacuum. So in the ancient time, people don't believe this. This only appear in 3 BC. So you see, it's after 3000 years. So we will let this symbol be natural number and we consider 0 in our definition. Some people start with 1, but we take 0 into n, okay? And in the ancient time, people also do not accept negative numbers. And around 200 BC, the Chinese use a negative number. Interestingly, at that time, they have negative number, but they do not have 0. And 0 is from India, around 6th century by these two, okay? Then we will define Z, which is German, means number for this. Since we define n including 0, so plus or minus 0 is also 0, so we only have 1 0. Other than that, 1, 2, 3, 4, 5, you have plus and minus side, okay? When you have natural number and you want to perform something called mathematics on natural number, so they will have the following property. This is called addition and this is called multiplication. Do not use this symbol, better use this instead, okay? So these 12 sentences are basically saying that all the number in Z, they have to fulfill these rules. You do not need to know these kind of names, not important. It looks fancy, but you already know all of them. In your high school, you make use of all of them. So this basically is a summary of all the rules you need when you calculate two integers or two numbers. The important message here is that based on this, you can prove a lot of things. For example, x squared minus y squared equal x minus y times x plus y. Actually, you can prove this based on this 12 sentence. So I can write this negative y as my plus a bracket negative y. Then this x multiply the whole bracket, give me this term. And then this bracketed term with a negative sign, go to here, give me this term. And what is this thing? This thing is P9. It's called multiplication is distributive. So A times a bracketed thing is the same as I do this. Then what's next? I have this form and this form. I'm going to redo this again. So x go into here, the negative y go into here, right? So I have this one. Then xx, I call it x squared. Okay, xy is just xy. This one, again, negative y is just this. Okay, so I have this, same here. And then now I have negative, so negative go here, and y, so I have y squared. And then x squared plus xy minus xy plus negative y squared. The difference is this two terms. This two terms is because of P8. A times B is B times A. Okay, this one is wrong. Okay, we should ignore it. Okay, so we have this. Then this xy and this xy, one is plus, one is minus, P3. A plus negative version of itself should be 0. So this is A, this is negative A, so this is P3, not P4. It's a mistake. Then these two terms, because of P3, okay, give me 0. What's next? Then I will have x squared, this. The 0 is gone. So because of P2, A plus 0 equal to A. So this x squared and this negative y squared is my A. This 0 do nothing on the A. And therefore, I have this, which is exactly here. Then I get this. So I have shown that from here, I get here. This one give me this one. Okay. I can also prove this one give me this one. I just go back from here all the way up. And I can do all these steps because I'm using the same argument. Therefore, I've shown that the left give me the right and the right give me the left. So they are equal. So this is an illustration saying that actually the mathematics you learn in high school come from something more foundational. And this is 12 sentence is something like that. In advanced mathematics, I'm talking about university level, this kind of thing has a name. They are called abstract group. This is something called group theory. We are not touching this in this module, so don't worry, but I just let you know this kind of thing has a name, okay? And because of that, if x squared equals y squared, we can have x equal y exclusive or x equal negative y. So how do you prove this? Okay, you can read it by yourself, okay? Then now we have finished about the integer, that means plus or minus natural number. Then we can also define q. Q is basically a fraction of m divided by n such that m and n are integer. So the essence is from n we can count positive integer. From this we can count positive and negative integer. From this now we can count fraction also with the integer because this is a subset, this is a subset, right? Okay, and of course this is also a subset, okay? Then now we can count anything that is integer, positive, negative, and also positive fraction and negative fraction. Here's an important property called Archimedean property. Basically the idea is that give me a number r is in q, there is an integer and that n is larger than the number you give me. So for example, if you give me 3/7, I can always find a number, n, that's larger than your fraction. Well, I can just say this is 10, done. Okay, basically the idea is saying that for any rational number r you give me, I can always find a number larger than the number you give me. So this is the idea about Archimedean property. And then later on, somebody found that not all numbers are rational. For example, square root 2 is irrational. That means there's some number, let me call it x, are not inside q. Then what's r? We can now define a number set called real number by saying that, okay, anything in q and anything not in q, we both group them together to form the r. R is like an extension or superset of q. So basically r includes q and irrational number. So we normally draw a line like this to say this is called real number line. So it's a representation of R. So on this line, we have all the number you know, and each point represents an element. That's basically an X in R. So basically, any number X is somewhere here. For example, half is here, 0 is here, -1 is here, pi is here, E is here, golden ratio is here, square root 2 is here. So everything here represents a number. And we can define a relation. So the R relation is this simple. So that means A, R, B. Now we are saying something A smaller than or equal to B. We kept this means this or this. Okay, that means if one of them is true, then this is true. Okay, so this is a binary relationship because we are talking about two things, A, R, B. This thing is reflexive. This is a revision of relation. Of course, A equal A. This symbol include equality. So A equal A. So that's correct. And then transitive, if A smaller than B and B smaller than C, then of course A smaller than C. Let me recap. If A point to arrow to B and B point arrow to C, so the directed graph representation of relationship is this, so A can go to C, okay? A is smaller than equal to A, so that means you have a figure that looks like A, okay? And same for B, and same for C, okay? And then if A is smaller than B and B smaller than A, that means A equal to B. This is a mistake, okay? Anti-symmetric, that means A smaller than B and B smaller than A, then these two will fuse together to a node, okay? That means you never see something that looks like this. And lastly, either A smaller than B or B smaller than B and no others. You have three, right? So now we group these two into this and group these two into that. So you either have this or that. And then this one, you don't need to know the detail. There are people who spend 36 hours in the math department to study this sentence. R is complete. It means there's no hole on the line. And the rational number Q actually have holes. So what does it mean? Suppose this is my number line and this is Q. Q is all the rational number, right? And since this guy is not rational, so that means if this guy is here, I have to dig a hole here. Okay, this represents square root 2. Similarly, square root 3 also is irrational. Actually, square root any prime number is irrational. So you have a bunch of holes, okay? Because all the square root of some prime number is irrational. So we actually will see a bunch of holes in the number line on Q. But you do not see hole for the case of real number. It's fully drawn, no hole. So this is the meaning. R is complete. This bracket is something very deep. I just explain it for fun. If you look at this R, what are the things that build this R? If I represent the thing in Q as red, and then for the thing not in Q, that means irrational number as green. Crazy fact is that on this line, most of the region are green. And actually, Q is the holes in this line. Okay, so that means what? That means in the real number line, rational number are actually the holes, not irrational number are the holes. And two examples of this kind of number is here. And these two numbers are the most important constant. One is pi, related to circle. One is E, related to a natural log. So pi, this is one definition, okay? This is given by Ramanujan, okay? You can represent pi as this crazy formula, okay? Nobody knows how did he come up with this formula, but this is insane. This number is irrational. That means it cannot be written as a fraction. This number is transcendental. It means there does not exist an algebraic formula, okay, that the root is pi. Basically, the meaning is this. That means if you want to have a function fx that is some polynomial, it's impossible to have one polynomial that the root of this thing is pi. And similarly, E also can be represented as a sum with a limit. And E have two definitions, okay? Both of them are the same thing, okay? E is also irrational and also transcendental. This is giving us an example that actually the holes on the real number are the Q themselves. And these are some additional things. We actually know nothing about number. For example, are these transcendental? We don't know. So there are actually more transcendental number on the real line. In fact, the holes on the real line are algebraic number, which include rational number. So that's insane. And then now, after real number, we have complex number, C, which defined as a real part plus an imaginary part. The imaginary part has this form. This is called I, imaginary unit, his square root -1, and then B is a real number. So we have this expression, and we will call A the real part, right, RE. B is called IM, which confused with the simple image in function or set. So this, be careful, okay? And we usually write complex number as Z, okay? And then if we write a bar on top, this is called complex conjugate. It looks similar to the set conjugate, so we can think of it as a similar thing. So you just make the complex part negative. So the meaning is you have a xy coordinate. This is the real part, okay? This is the real part. This is the imaginary part. So you have A plus BI. Let's say I have 1 plus 2i. Then I have x coordinate 1, y coordinate 2. So this is the point. This is my z, okay? What is the z bar? Z bar means the y coordinate, I flip it. So same x, but negative y. So basically it's like mirror image, I flip it. So this will be my z bar, okay? Complex number z, so basically means these 2 points, I add them up. So the y coordinate cancel out, but the x coordinate will be double. So I need to divide by 2 to get back the x coordinate. Same for the imaginary part. So this should be subtractions. And this is called conjugate of z. This is conjugate of conjugate. So that means, it means double conjugate means do nothing. IDZ. Okay, ID from the logic means identity operator. That means do nothing. Size of a z or modulus of a z is the same as z times z bar or z times z conjugate, which is this. Okay, I also make a mistake. This will be b. Okay, but anyway. And lastly, this is called polar form. So any complex number can be written as r times ei theta. This thing is a coordinate representation in the rectangular coordinate. But I can also represent this as this is my r and this is a theta. So my r will be, by Pythagoras theorem, it will be 1 squared plus 2 squares square root, which is square root 5. Okay, and this theta will be what? Y divided by x is a tangent theta. So tangent theta is 2 divided by 1. So theta is arctangent 2. This 1 plus 2i is the same as square root 5 ei, this thing, arctangent 2. Okay, they are the same thing. One is using rectangular coordinate, another one is using circular coordinate. Okay, something like this. Okay, and then actually, so just quick recap: rectangular coordinate means everything looks like this. Circular coordinate or polar coordinate, the coordinate looks like this. Okay, and then you have this, this, this. So it looks like radar. On this line, all the points on this line have the same theta. All the points on this circle have the same radius. In here, all the points on this line have the same x. All the points on this line have the same y. And then now here are something called basic topology. If I write open bracket AB, that means I'm considering all the x between A and B with strict inequality. If I write a square bracket, that means I consider A, B are included. Okay, I can have this. This means A is included, B is not included. Same here. Then what is real number? Real number I can written down like this. Since this bracket means I do not include the two ending points, that means this one we talk about later. Now this part definitely no need. This is just for fun. Okay. Important. You can actually show that this is false. R is not a subset C, but you can also say that R is a subset C. It depends on the context. So I will just put an exclamation mark here. Then actually from here onward, you always have this. Okay. Then you may wonder what's the next one. Is it complex number with 3 thing? No. It turns out the next one will be something have 4 things. This is called quaternion. H stands for Hamilton. Okay, so you write this, and then you may wonder, what about this? You have 8 things. This is called octagon. Okay, and then you have 16, 32. Okay, you now see some pattern. 2 times, 2 times, 2 times, 2 times, 2 times. Yes, and for this funny thing, now instead of one complex part, you can think of it as complex number. Now all the ijk square give you -1, but at the same time, ijk give you -1. You are not going to see this until you do something in computer graphics or robotics. For those who know physics, sometimes you need to do something called cross product. Okay, or electric field, and then you do a left hand rule or right hand rule, something like that. That is exactly 3-dimensional rotation thing. This kind of thing, in the end, is just this guy. So that means to describe some cross product right hand rule, left hand rule thing in physics, or cross product in vector, actually you are doing something called quaternion. And then there are also some other crazy things. You can Google them and watch YouTube video on them.